Problem sheet 5, question 2. Use the simplex method to solve the following linear programming problem. Maximize 3x1 plus 5x2 subject to minus 5x1 plus 17x2 is less than 425. 5x1 plus 4x2 is less than 205. x1 and x2 are both non-negative. The first thing we will do is write this in standard form, where we will write all our constraints as equalities with slack variables. So we can rewrite this as maximize 3x1 plus 5x2 subject to minus 5x1 plus 17x2 plus our first slack variable s1 is equal to 425. Now our second constraint, 5x1 plus 4x2 plus our second slack variable is equal to 205, where x2, s1 and s2 are all non-negative. From this we can write down our initial simplex tableau, where we will write our columns will correspond to each of our four variables, x1, x2, s1 and s2. Every row will correspond to a constraint. So the first constraint, our right hand side, which I'll put in the left hand column, was 425. The coefficient of x1, minus 5, x2, 17, s1 was 1 and s2 was 0. Our second constraint, and once we've written all our constraints in, the final row will be our objective row. So our objective, we always begin at the point 0, 0, which corresponds with an objective value of 0, and our objective function was to maximize 3x1 plus 5x2, and we will put those coefficients in negative, because this is a maximization problem. So the coefficient of x1 was 3, so we will write minus 3, and the coefficient of x2 was 5, so we will write minus 5. We had 0 for the coefficients of s1 and s2. To carry out the simplex algorithm, we'll first find our pivot. So we want to find the most negative value in the objective row. This will be minus 5 corresponding to x2. And to find our pivot, we will take the ratio between our left-hand side and our work column x2. So 425 divided by 17, that is 25. 205 divided by 4, that is just over 50. So the least positive value there is 425 divided by 17. And so this becomes our pivot. We then want to perform row operations so that our row column becomes 1, 0, 0. And our row operations will be the current row plus or minus some multiple of the pivot row. So row 1, our new row 1 will become whatever row 1 was multiplied by 1 over 17. So that will give us a 1 where our pivot is. What about row 2? Our new row 2 will become whatever row 2 was plus or minus some multiple of our pivot row. However, our new R1 is a multiple of our pivot row, and we know that will give us a 1 at our pivot. So we could minus 4 lots of our new row 1. That would give us 4 minus 4 times 1, because 1 will be in our new row 1. Similarly for row 3, our new row 3 will be our old row 3 plus 5 lots of our new row 1. So we can perform these row operations and write down the next iteration of our simplex tableau. So the first row divided by 17. The second row will become our old second row minus 4 lots of the new first row. So that'll be 205 minus 4 lots of 25 gives us 105, and so on. And our third row will be our old third row plus 5 lots of our new first row. So here we'll have 0 plus 5 lots of 25 There's 125, and so on. Now we still have a negative value in our objective row, and so we will pivot again. So choosing our next pivot, you want to choose the most negative value in our objective row. Here there's only one negative value in our objective row. Now we want to choose the least positive ratio when we divide our left hand side column with our pivot column or work column. The only one that will give us a positive value here is 105 over 17. Therefore, we need to choose our row operations. In this case, we know that our new row 2 will be our old row 2 times 17 over 105. That will give us a 1 here. And all the other row operations, we are trying to get zeros in the rest of this column. So our new row 1 will become our old row 1 plus 5/17 of our new row 2. Our new row 3 will become our old row 3 plus 76 over 17 lots of our new row 2. So we can write down the next iteration of the simplex tableau by performing these row operations. After this iteration, our objective row has no negative values in it, and so we finish the simplex algorithm, and we can read off our solution. The way we read off our solution is we recognize that we have two basic variables, x1 and x2. We know they're basic because they have 1, 1 and the rest zeros in their column, and two non-basic variables, s1 and s2. The non-basic variables are set to 0, s1 is equal to 0 and s2 is equal to 0. And our basic variables are set to the values of the left-hand column in the rows where their 1 appears. So x1 will be equal to 17 and x2 will be equal to 30. That actually gives us an objective value of this number here, 201. We can double check that. Our objective was 3 lots of x1 plus 5 lots of x2. That will give us 3 lots of 17 plus 5 lots of 30. And that does indeed give us 201. So this would be our solution.